Okay, so we're going to have a look at a question from a university. So this comes from a uni Calc 2 paper, Calc 2. So we're told question 1 is worth 2 points. Compute the sum of the infinite series. So we have the sum from k is equal to 1 to infinity of 2/3 multiplied by 3 on 4 to the k. So every term in this series gets multiplied by 2/3. So we know this is the same as 2/3 times the sum from k equals 1 up to infinity, 3 on 4 to the k. And now all we really need to do is calculate the value of this, multiply it by 2/3. So if we think about this series, this is 3/4, because it goes from 1, plus 9/16 plus 27/64, and so on. And so this is an infinite geometric series, and we could rewrite this in a slightly different way. We could say that we actually have the multiplication factor, which we might call m, is 3 on 4. So we're multiplying each term by 3 on 4. The initial term is 3 on 4. So the initial term is 3 on 4. And we have the sum of an infinite geometric progression. So we have sum of infinite progression is equal to the initial term I divided by 1 minus the multiplication factor. So for this question, we can just plug these numbers in. So we know this to be true for infinite sums where the multiplication factor is less than 1. The absolute value of it is less than 1. So this is 3/4 divided by 1 minus 3/4, which is 3/4 over 1/4. The quarter bases, quarter denominators will cancel. This is 3. So therefore, the infinite sum from k equals 1 up to infinity of 2/3 times 3 on 4 to the k will be equal to 2/3 times 3, which will be equal to 2. And so of the 4 answers here, C is going to be the answer that we want. So this was one way to go about this question.